Raina, Silva, Simran, Suti, boleh? Sudin. Nice. One more. One more. Very important words. Basic point principle. Sirai. Kalau mau masuk sirai. Sirai is a very important conversation which is often many times in the meetings.
Sir, release. You want to also sir?
We can go today and next class we are going to be paying very important. Some of mostly keep okay. Yes, the line of class. Yes, what was our
Only. Sir, wait for 2-3 minutes, sir. 5 minutes, sir. Start ಮಾಡ್ರೆ ಆಮೇಲೆ ಅವ್ರು ಬೇಕಾದ್ರೆ ನೋಡ್ಕೊತಾರೆ ಸರ್ ಲಿಂಕ್ ಸೇವ್ ಆಗುತ್ತೆ ಸರ್ ಆಟೋಮೆಟಿಕ್ ಸೇವ್ ಆಗುತ್ತೆ ಕ್ಲಾಸ್ ಆದಮೇಲೆ ನಾನು ಕರೆದು ನಾನು ಸೇವ್ ಮಾಡ್ತೀನಿ ಸ್ವಲ್ಪ ಸ್ಟಾರ್ಟಿಂಗ್ ಗ್ಯಾಪ್ ಆಗಿರ್ತದಲ್ಲ ಅದು ಕಟ್ ಮಾಡಿ ಹಾಕ್ತೀನಿ
ಯೂಟ್ಯೂಬ್ ಅದು ಆನ್ಲೈನ್ ನೋಡ್ಬೋದು
ಹಾಂ ಲೈವ್ ನೋಡ್ಬೋದು ಆಮೇಲೆ ಬೇಕಾದ್ರೆ ನೋಡ್ಬೋದು ಒಂದು 2-3 ಮಿನಿಟ್ಸ್ ಬಿಟ್ಟು ಸ್ಟಾರ್ಟ್ ಮಾಡೋದು ಅವ್ರು ಆಮೇಲೆ ನೋಡ್ಕೊಳ್ಳೋಕೆ ಬರ್ತಾರೆ ಸರ್ ಒಂದು 2 ಸೆಕೆಂಡ್ಸ್ ಹಿಂಗೆ ಮುಂದೆ ಬರ್ತಾರೆ ಸರ್ ನಾವು ಮಾಡಿದ ಆ್ಯಕ್ಸೆಂಟ್ ಆಮೇಲೆ ಅದು ಕರೆಕ್ಟ್ ಆಗುತ್ತೆ ವಾಯ್ಸ್ ಎರಡು ಎಟ್ ಎ ಟೈಮ್ ಬರ್ತದೆ
ಥ್ಯಾಂಕ್ ಯು Good afternoon, students. Good afternoon, students. Myself, VK Kulkarni. I'm dealing with your physics subject. Today we're going to discuss regarding Introduction to Physics, Part 1. So, the topic of today's discussion is the physical world. The physical world. In fact, before 18th century, there was only one subject that was known as natural philosophy. Among that syllabus, in fact, of that particular subject, all phenomena and concept of science got included. But later, it's been classified into three classes. That is physical sciences, number one. Number two, chemical sciences, and number three, biological sciences. Physical sciences, number one. Number two, chemical sciences, and number three, biological sciences. Physical sciences, number one, it deals with the physical object, and it mainly deals with energy and matter. Energy and matter. Then the second one, the chemical sciences. Chemical sciences dealing with the chemicals and chemical reactions. Then lastly, biological sciences. Biological sciences, it deals with living beings such as animals and plants. Living beings such as animals and plants. Today we are going to see the physical sciences, it deals with energy and matter. In fact, before going to that,
red and green, blue color. Look at them.
ವಾಯ್ಸ್ ಕೇಳಿ ಬರ್ತಾ ಇದೆ. Now, before discussing the physical sciences, we're going to see the term science. What is science? Science, it is dealing with nature and natural phenomena. Science, it deals with nature and the natural phenomena. Natural phenomena like what we come across in the day-to-day life, like lightning, thunder showers, formation of cloud, falling of rain, formation of rainbow, changing of seasons. So these are all natural phenomena. The gravitational force is also one of the natural phenomena. When an object is dropped from certain height, which is falling towards the ground, it is due to the gravitation. Gravitation, it is a universal natural phenomenon. In fact, the word science derived from Latin language that word is scientia. The meaning of this Latin word is to know or knowledge. Is to know. Meaning of this Latin word scientia means to know or knowledge. To know about our nature and natural phenomena, to know about nature and the natural phenomena. It means science, it is dealing with nature and the natural phenomena. Now, come to the subject of physics. Physics, as you know, it is a branch of science which deals with two entities. One is energy and another one is matter. It deals with two entities. One is energy and other one is matter. Other one is matter. In fact, the word physics is derived from Greek language. Derived from Greek language. That word is physis. Meaning of physis is nature. Means physics, it is a branch of science which deals with nature and the natural phenomena. Apart from that, in fact, in that it is dealing with two entities, energy and properties of matter. Remember, it deals with energy and properties of matter. Physics, it is a branch of science deals with energy and properties of matter. Energy and properties of matter. Now, going to see what is energy. Energy means what? Energy, it is a capacity to do work, is known as energy. This is one concept. In fact, there are many types of energies. Energy, the light energy, sound energy, wind energy, so etc. There are many types of energies. According to law of conservation of energy, the energy neither created nor destroyed. Energy is neither created nor destroyed. It can be converted from one form of energy into another. For example, you might have seen windmills. In that, the wind energy that got converted into electrical energy. From dynamo, the mechanical energy get converted into electrical energy, like that. So energy is neither created nor destroyed. It can be converted from one form of energy into another. One form of energy into another. So the specific definition for energy that in the mechanics we are seeing here on the board, that is the capacity to do work. This is a simple definition for energy. What is energy? Energy, it is a capacity to do work. Then next entity of physics is matter. Matter. What is matter? Matter, it is what? Anything which occupies space and has some mass. Anything which occupies space and has some mass, that we are calling it as matter. What is matter? Anything that occupying a space and that is having certain mass, that we are calling it as matter. In fact, as you understood now, the physics, it is a branch of science which deals with two entities, energy and matter. Energy and matter. Then question arises, by the definition of matter, what is mass? What is a mass? Mass is what? Mass, it is the amount of matter contained in a body is known as mass. The amount of matter contained in a body is known as mass. Now, we're going to see few examples for a natural phenomena. The phenomena occurs in nature. Naturally it occurs that we come across in our day-to-day life. That natural phenomena, we're going to take one example and we'll see how it happens. See, the phenomena like lightning and thunder. Lightning and thunder, in fact, all of you observe in a day-to-day life. As we have observed, according to that, we see the lightning in the sky first, later we hear the sound of a thunder. Sound of a thunder. My question is, how many of you given stress to your brain, why it is happening like that? Why it is happening like that? Why? You can see the lightning first, later we hear the sound of a thunder. Reason is, in fact, the speed of light in air or vacuum is 3 into 10 to the power 8 meter per second. This is the speed of light in air or vacuum. Whereas speed of sound in air or vacuum is approximately 340 meter per second. See these two things. Speed of light in air or vacuum is quite high. This is in terms of 10 to the power 8, 3 into 10 to the power 8 meter per second. Whereas speed of sound in air or vacuum is just 340 meter per second. This is the reason why first we see the lightning in the sky, later we hear the sound of a thunder. This is the reason for this particular natural phenomenon. Another one, see, when you drop an object from certain height, it falls towards the ground. It's falling towards the ground. So, what exactly the reason behind that? Why it is falling down? Why it is not going up? What exactly the reason? In fact, the reason is, it is due to gravity. What is gravity? Gravity, it is a gravitational force of attraction between Earth and a body. Means the force of attraction with respect to Earth, that we are calling it as gravity. Force of attraction with respect to Earth, that we are calling it as gravity. See, there are two words. One is gravity, one more is gravitation. Gravity, the gravitational force of attraction with respect to Earth, that we are calling it as a gravity. What is gravitation? Gravitation, it is a universal word. It is the gravitational force of attraction between any two bodies in the universe. Gravitational force of attraction between any two bodies in the universe. That we are calling it as a gravitation. That we are calling it as a gravitation. It is governed by the famous law. That law we are calling it as Newton's law of gravitation. This phenomenon is explained by Sir Isaac Newton, given the abstract that we are calling it as a law of gravitation. Law of gravitation. Since we are discussing regarding the gravitation and the gravitational force, to go in depth to study a physical quantity known as force, that we are going to discuss in detail. That physical quantity is a force. Force, in fact, this word is quite familiar to everyone. Each one of you know this word. But according to physics, what is force? Force, it is a physical quantity. It is a physical quantity or an external agent used to displace a body from its original position, or it is a physical quantity used to stop a moving body. What is force? Force is an external agent. It is an external agent. It is used to move a body which is at rest, or used to displace a body which is at rest, or to stop a moving body. The physical quantity which applied in these two cases, that physical quantity known as what? Force. Known as what? Force. In fact, in nature, there are four fundamental forces. Fundamental forces in nature. Fundamental forces in nature. There are four fundamental forces. There are four fundamental forces found in nature. found in nature. Number one, gravitational force. Number two, electromagnetic force. Number three, strong nuclear force. And number four is weak nuclear force. These are the four fundamental forces in nature. These four fundamental forces we find in nature. Number one is gravitational force. Number two, electromagnetic force. Number three, strong nuclear force. And number four, it is weak nuclear force. Weak nuclear force. We're going to study these fundamental forces one by one. We're going to study these fundamental forces one by one. Fundamental in the sense what? What is fundamental? Fundamental means basic. Fundamental means what? Basic. These are the four basic forces found in nature. These are four basic forces found in nature. We're going to study in detail regarding these forces, these fundamental forces, one by one. The number one fundamental force is gravitational force. Number one fundamental force is a gravitational force. As just we come across the two words gravity and the gravitation. Gravity, it is a gravitational force of attraction between an object and earth. And gravitation, the gravitational force of attraction between any two objects in the universe. So gravitational force, it is the weakest among all fundamental forces. Gravitational force, it is weakest among all fundamental forces. Gravitational force, it is a central force. Gravitational force, it is a central force. Central force. And this gravitational force obeys universe inverse square law. It obeys inverse square law. And the gravitational force which exists between any two objects, of say mass m1 and m2, these two are the objects. These two objects separated by what? Distance r. The force which is acting at the center of these two bodies. Because of that reason, we are calling the gravitational force is a central force. This gravitational force, it is a long range force. Gravitational force, it is a long range force. Means there is a gravitational force between Earth and the Sun, the gravitational force between Earth and the Moon, gravitational force between all the heavenly bodies such as planets, stars, comets, meteoroids, asteroids, etc. All means the gravitational force exists between all heavenly bodies. The gravitational force, since we are saying the gravitational force, it is a attractive force. It is only a attractive force. These are the two bodies. One is of mass m1 and another is of mass m, separated by a distance r. So it is acting at the center of these two bodies. The gravitational force, which is directly proportional to the product of masses of these two bodies, and this gravitational force is inversely proportional to the square of the distance between these two bodies. It means the gravitational force, it is directly proportional to m1 into m1 m2, m1 into m2 divided by r square. The gravitational force, it is directly proportional to the masses m1 and m2 and inversely proportional to square of the distance between them. See, one thing you remember, whenever you are equating the physical quantities, there is a proportionality constant exists. Here, we have proportionality constant G into m1 into m2 divided by r square. This G, we are calling it as universal gravitational constant. Universal gravitational constant. G, we are calling it as universal gravitational constant. Why we are calling this proportional constant G as a universal gravitational constant? Reason is the value of this constant remains same throughout the universe. Value of this constant remains same throughout the universe. Because of that reason, we are calling this proportionality constant as a universal gravitational constant. This is regarding a gravitational force. In fact, one more thing is the gravitational force which exists between the two bodies. It is due to exchange of an elementary particle called graviton. The elementary particle graviton, which is exchanged between the two bodies. Due to that particular factor, the gravitational force exists between the two bodies due to exchange of the elementary particle called graviton. Because of that reason, the gravitational force which exists between the bodies of two masses M1 and M2 as mentioned in this example here. The second fundamental force is electromagnetic force. Electromagnetic force. What is this electromagnetic force? See, we have a charge Q or a body which is charged to a charge Q. The space around this body, that we are calling it as electric field. See, we have Q charge here, and at this particular point we have placed a charge Q naught. The magnitude of this is say 1 coulomb. Coulomb, it is the SI unit of charge that you are going to know in the coming days in PUC second year. See, this Q naught is the unit positive test charge. The force experienced on this unit positive test charge due to this charge Q. This charge we are calling it as a source charge, and this one we are calling it the test charge. So the force which experienced by this unit positive charge Q naught, that force we are calling it as electric force. That force we are calling it as electric force. See, this charge, when it is moving with velocity v, then what happens? Then this charge is producing both electric as well as a magnetic field. In magnetic field, certainly there is a force which we are calling it as what? Magnetic force. What is that? That is a magnetic force. Means the electromagnetic force, it is due to electric and the magnetic force. This electromagnetic force, it is stronger than gravitational force and a weak nuclear force. Gravitational force and a weak nuclear force. This electromagnetic force is attractive or repulsive force. It may be attractive or repulsive force. It means what? See, when two charges, this is plus charge and this is also plus charge, separated by certain distance r, the force between these two charges is a repulsive force. Repulsive force. Because the like charges repels each other. Like charges repels each other. If this charge is negative and this charge is also negative, then what happens? Again, these two charges are like charges. Again, the force between these two charges is repulsive force only. Then, if these two charges are unlike charges, this is negative and this charge is positive, then what will be the force between these two charges? Force is what? Attractive force. What is that force? Force is attractive force. When the two charges are unlike charges, the force between two charges is attractive. Means unlike charges attracts each other. Unlike charges attracts each other. As gravitational force, this is also a central force and this is also obeying inverse square law. Inverse square law. So electromagnetic force also obeys inverse square law and this is also a long range force. Long range force and it is stronger than gravitational and a weak nuclear force. Gravitational and a weak nuclear force. See, we are considering two charges Q1 and Q2 separated by certain distance r. We don't know whether these charges are positive or negative. Then the gravitational force. Now, here which force comes? Here, when these two charges are at rest, then the force which is an electrostatic force. When the two charges are at rest, the force between them is electrostatic force. When these two charges are moving, the force between them is electromagnetic force. When there is an addition of electric and magnetic force, and that force we are calling it as Lorentz force. So the electrostatic force is directly proportional to what? The product of two charges. Remember, these two charges, we are saying these two charges are point charges. These two charges are point charges. So, the electrostatic force of attraction or repulsion between these 2 point charges is directly proportional to the product of magnitude of 2 point charges and inversely proportional to what? Square of the distance between them. This we can write it as what? F is directly proportional to Q1, Q2 divided by r square. This is equal to a proportionality constant k into Q1, Q2 divided by r square, where k is equal to 1 by 4 pi epsilon naught. Where epsilon naught, it is the permittivity in a free space. Epsilon naught is a constant. So that constant we are calling it as permittivity in a free space. And this is governed by law that we are calling it as Coulomb's law in electrostatics. Coulomb's law in electrostatics. So Coulomb's law in electrostatics, it states that the electrostatic force of attraction or repulsion between 2 point charges is directly proportional to product of these 2 point product of magnitude of these point charges and inversely proportional to square of their distance between them. Square of the distance between them. So, in the tomorrow's class, we are going to see in detail regarding strong nuclear force and a weak nuclear force. And we are going to see the principal thrust in physics, excitement of physics, physics in relation with society and technology. That we are going to see in the next class. Thank you. Hello sir, class will be. So,